Woohoo! We're back! Today we're going to be talking about the quadratic formula and how to use it to solve quadratic equations. Yay! So, first one, what is it going to look like? Well, the actual quadratic formula looks like this, and there are two parts to it. One is that you need to have a quadratic equation. And we're going to write it as ax squared plus bx plus c. So in descending order, and it has to equal 0. If all of this is true, then x is given by this formula. And the formula looks a little imposing, but once you practice with it, it's not so bad. You get practice, you do a bunch of problems, and it ends up that the quadratic formula ends up being faster, usually, than completing the square. So that's why it gets used a lot. And if you watched the last video, you know that it is actually just the formula we get from completing the square. So it's just a shortcut. You don't have to go through all of the steps because the steps are, this is like the microwave version of those steps. So what does it look like to use this formula? So first off, we've got to have a quadratic equation right there. So we do 2x squared plus 6x plus 3 equals 0. The 0 is what's important, along with the x squared. We need an x squared and we need a 0. 0. Once we have that, then we just have to line this up with ax squared plus bx plus c, so that we can find out what a is. A is 2, b is 6, and c is 3. Okay, so that's the first part. And then we just write out the formula here. X equals the opposite of b plus or minus radical b squared minus 4ac all over 2a. Now, that is a whole mouthful, and it's a lot to memorize. And it's not simple to memorize it. So the question then becomes, how do you remember this? And the answer is, well, some people just practice it a lot and learn it. But the other answer is you can put these steps to song. And if you look up online, you can find that people have used all manner of popular songs. All different types of music have been used so that you can practice singing this. And that way, that's the way you remember it. So definitely look online. There are a bunch of different versions for this. And you could even write a new one, get internet fame for writing this, making a video about singing this to Beethoven or whoever you'd like to sing it to, Dio. That would be fun. Okay, so I'm going to go ahead and use this. I've got it written out. So my x in this case will be the opposite of b. So it's whatever b is, but change the sign. So it's the opposite of 6, then a plus or a minus, then a radical, then whatever b is squared. So this is going to be 6 squared minus 4 times a, which is 2, times c, which is 3, all over 2 times and a again, so 2 times 2. Okay, so let's see. I get negative 6 plus or minus radical or square root. 6 squared is 36. 4 times 2 is 8, times 3 is 24, all over 4. Okay, not too bad so far, not too bad. Now, we are going to have to simplify this a bit. So it's negative 6 plus or minus, and then 36 minus 24 is 12, all over 4. And now the problem comes up that we have something in a square root right there that isn't nice. It's not a perfect square. So we're going to have to simplify it. So I'm going to go ahead and write this down on the next page, and then we'll continue there. So the answer we just were working with was that x equals the opposite of 6 plus or minus radical 12 all over 4. Okay, so first thing I'm going to do is I'm going to use bare math Rawr. I'm going to use bare math to simplify radical 12. And I'm going to write out that that's 4 times 3, which is 2 times 2. So inside my radical, I've got 2 times 2 times 3. Okay, so the rule is, if you've got any twins, send them running. Yum, 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 yum. Okay, 1, 2 makes it out, and the 3 stays inside. So I'm going to take the radical 12 and replace it with 2 radical 3. This is where things get exciting. Now, if you've been in my class at all, you've probably heard me say that, contrary to popular belief, addition and subtraction are actually awful. Multiplication and division, generally pretty easygoing, but addition and subtraction are a big pain, and they are in this case. This plus and minus in the middle mean that this all has to be canceled very carefully. You can't just cancel things willy-nilly. And specifically, anything you cancel on top has to come out of both this term and this term. So what we usually do to reduce is that we factor out common factors. So I look at 6, -6, and 2, and I think, they have 2 in common, so I'm going to factor that out. So what's left? I've got -6, divide out the 2, that leaves -3, and then I take out the 2 that's here, so I just have the radical 3, all over 4. Once I've got that, and there's a number out in front, this is one term. This is all smushed together. I've got the 2 that came out of both. So when I cancel, I will be canceling from both. And now I can cancel the 2 with the 4. And granted, this is a lot. So, I'm not suggesting this is easy peasy. I'm telling you this is a little bit easier than completing the square. And in this particular case, it would not be possible to factor. So you would have to use either the quadratic formula or completing the square. So I've got 1 times the quantity, -3, plus or minus radical 3, all over 2. Now 1 times something, that's just itself. So I can write x equals the opposite of 3, plus or minus radical 3 over 2. Now, depending on the situation, that could be your answer. I mean, that is an answer. It is reduced, but it may be that you're in a situation like in WebAssign that you have to write them separately. So you could write x equals -3 plus radical 3 over 2, or -3 minus radical 3 over 2. Or it's even possible that someone wants you to split them up more. You can write -3 halves plus radical 3 over 2, or -3 halves minus radical 3 over 2. These are both alternate solutions. But this is it. That's your answer. And even though there are a lot of steps, in general, the steps are the same each time. So it's possible to practice. That's what makes this a nice formula, even though sometimes it's a little grody in the middle. Okay, shall we try another one? Woohoo! Yes, let's do another one. Yay! This is so exciting. We love math. Dun, dun, dun! Oh no! Oh no! What are we going to do? Well, let's use the quadratic formula. So, what happens if we get x squared equals the opposite of x minus 5? There's no 0. Oh no, no 0. Oh no. Well, then we need to make a 0. And you get to choose. Generally speaking, to use the quadratic formula, everything has to be on one side. So you can move everything onto the left, or you can move everything onto the right. It will work both cases. And it looks like we're about to get some help. Chai has sensed that you are all very nervous, so she's here. You can pet the screen briefly. She's here to help you all out. Say bye, Chai. Goodbye. And Chai will be just off to the side, so you can pet her off to the side. She's fine. She's got a whole comfy chair that she sits in and watches. Unless she's worried. She's obviously worried that you guys are very nervous about this. So she's trying to help out. She's like, no, I need to help them right now. Okay, let's go ahead and let's hope that they're going to be okay. I will show them how to do it. They'll be fine. Okay, she's very worried about you. So she's sending you, snuggly purrs and claws so that you can get through this. So what I'm going to do is I'm going to move all the terms onto the left. The reason I'm going to put them on the left is because the x squared is positive, and I find that easiest. If you want to subtract the x squared, move it onto the right. You go for it. You'll get the same answer. You just might have some different steps to take. So I'm going to add x and add 5, and you're absolutely allowed to add 2 things at a time. You don't just have to add 1. And I'm going to get x squared plus x plus 5 equals 0. And now we've got the 0. The 0 is very important. You need a 0 on one side or you cannot use the formula. Okay, so now let's write out the formula. This is one of the ways you learn it, is by writing it out a million bazillion times. Okay, so I've got x equals the opposite of b plus or minus radical b squared minus 4ac all over 2a. So, in our case, what are a and b and c? So let me write it here. A is 1, b is 1, c is 5. Okay, so let's write this out. X equals the opposite of 1 plus or minus square root of b squared, so 1 squared minus 4 times 1 times 5 all over 2 times 1. Oh my goodness. Chai really is trying to help you out. She's now standing on the keyboard, which I put over to the side where she couldn't get to it, but turns out she can. Okay, so that makes this very exciting. So let's keep going. And some of you might have noticed, oh no, something weird is happening. Don't panic. Don't let your brain panic at it. Oh, sorry about that. Don't let your brain panic. We're just going to step through this. So I get -1 plus or minus radical 1 minus 20 all over 2, which is equal to -1 plus or minus radical -19 all over 2. Now what? Well, in this case, unfortunately, this is a negative number inside a square root. This part is not real. Sorry, Chai is now in my lap. Stop. So, this is not real. Chai is very worried. She's trying to save you from the imaginary answer. So, the thing is, in the very next section we come to, we're going to talk about what to do. But for right now, if you're in a problem set where you can only answer with real answers, you would have to say no solution. Once we get through 1.5, we'll be able to come back and say, oh, we'll use imaginary numbers. And then we'll be able to look at that answer and make sense of it. But for right now, no solution. Woohoo. So, this is kind of an interesting thing. This formula comes with this square root. And the square root is dangerous because we can end up with negative numbers inside, and then that's not real. So is there a way to know that this would happen? And the answer is dun 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 dun, or dun dun dun, your choice. The discriminant. In the quadratic formula, the part inside the radical, so let me show you, let's get that visual aid back up here. The part inside the radical, that part right there, b squared minus 4ac, is called the discriminant. And what it does is it tells you whether or not this square root is going to behave itself or not. Like Chai, whether Chai is going to, she is staring at me, she's staring daggers at me that I would dare give you such hard problems. She's very worried for you. So the discriminant is what tells us whether or not we can actually use the formula. So if the discriminant, if the thing inside the square root is 0, then the quadratic equation has exactly one rational solution. So there's a fraction or a whole number or an integer of some sort, and the quadratic can be factored. So the cool thing is if you take b squared minus 4ac, you will know whether that quadratic can be factored, which is cool. That's the problem we're going to answer right here. If b squared minus 4ac is greater than 0, then the quadratic equation has exactly two real solutions. It might also be able to be factored if whatever's inside the discriminant is a perfect square. So we've got, if it's equal to 0, the quadratic equation has exactly one rational solution. And if it's greater than 0 and it's a perfect square, then it can also be factored. If it's greater than 0, you still have a real solution, but you might have one of those solutions where it involves like the square root of 2 or the square root of 17. If the discriminant is negative, then the quadratic equation has exactly two complex solutions. I'm going to write here the solutions are not real. Okay, so that if you're working with real numbers like we are in 1.4, you would say there's no solution. After 1.4, when we get into 1.5 and talk about complex numbers, then we can start talking about imaginary and complex answers. So the question I want to ask is, if you get this, just a generic quadratic, 5x squared minus 3x plus 2. So a is 5, b is negative 3, you got it. C equals 2, yep. Then if we put together the discriminant, so b squared minus 4ac, that's going to be, now be careful with the b squared. B in this case is negative, so make sure you square the whole thing. B squared minus 4 times a, which is 5, times c, which is 2. So let's look here, this is 9, and then that's, I think that's going to be 40. So we get negative 31. That's less than 0. So what does that mean? The quadratic equation has two complex solutions. They're not real. Oh, you can't see that. I'm sorry. The solutions are not real, which means I should write here the quadratic. I can't spell. So sorry. The quadratic cannot be factored. So this is less than 0. So the answer is no. It can't be factored. So why is the discriminant useful? The discriminant is useful because before we put a bunch of work into something, it'll tell us whether or not we should do the work. If we're looking for two real answers, or if we're looking to factor this, should I try the AC method? Should I try trial and error? The answer is no. This can't be factored, so I shouldn't put the work into it. So, woohoo! This is the end of this chapter. Woohoo! Obviously, if you have any questions, please ask me. Please sign up to talk to the tutors. We would love to help you. The quadratic formula is a topic that will continue to be important pretty much almost as far as you go in math. Certainly if you're not majoring in math, but if you're majoring in something like engineering or the sciences or architecture, even medicine, and you have to take a bunch of calculus classes, you're gonna need the quadratic formula. So it's important that you put the time in now. Make sure you understand it. And if you do have any questions, please do not hesitate to ask. I would love to answer them. But for now, the video's gotten kind of long, so I'm going to sign off. Wish you all an awesome day, and know that I think you're amazing and brilliant, and I hope you all math on.